Hello, welcome. I'm here in this video to talk some more about computer vision. Computer vision being this idea of having a computer see, having a computer find something. If you notice, there's this strange red cup. This actually isn't part of my computer screen. This is a red cup here taped to the wall behind me. And in a second, I'm going to have a camera pointed at that. And I want the computer to be able to find that red cup. And this is going to open up a lot of questions around all sorts of different techniques and strategies of getting things that are faster and more accurate and that sort of thing. So the first thing that I want to do, though, is reference for you a source of inspiration for me, which is an article by Golan Levin called Computer Vision for Artists and Designers, Pedagogic Tools and Techniques for Novice Programmers. So there's a link to this article in the description. It gives you some historical context, and it also walks you through some sort of key classic techniques like detecting motion, detecting presence, detection through brightness thresholding, simple object tracking, etc. And I'm going to demonstrate a lot of the techniques which I've learned and taken inspiration from this particular essay, online essay. So, okay. So the other thing I'll mention briefly is what my strategy here for this set of tutorials, there's going to be a whole bunch of them. By the time I'm done, there could be up to 10 even, is that I'm going to show you how to program some of these classic algorithms from scratch. And then from there, I'm going to transition to showing you how to use different computer vision libraries that have these algorithms and more sophisticated versions of these algorithms baked into them. So it's a question of, in practice, a lot of the time you probably want to just use a library like OpenCV is one of the ones I'm going to show you. But there's some value in understanding the algorithm for when you go to use the library, for knowing how it works. Plus, you might invent some sort of wacky, creative new ideas around computer vision and just sort of creative visualization by playing around with these, by writing the algorithms yourself. Okay, so a previous video, I started with an example that does exactly this. So, and this is an example running in processing, a Java-based platform. I will make P5.js JavaScript versions of these examples, which you can find hopefully linked in this video's description as well. But here you have a cup, a cup taped to a green wall behind me. And what you can see here is that I'm drawing a circle at that cup's location. Now, how did I do that? The way that this particular algorithm works is it says, look at every single pixel. Is that pixel red? Is that pixel really red? Is that pixel more red than the other one I found that was kind of red? It's looking for the most red pixel. For every pixel, find its color distance, its difference from red, and find the one that holds the record for being the most red, and then draw a circle at that location. But there's an issue. While this is working somewhat accurately, I could even take this off the wall. You can see it's kind of following it around, but it is sort of jiggling. I could also demonstrate another problem by having two cups now, and now it's jumping back and forth between the two. So there's a lot of things that I want to resolve here in the way that I'm going to improve these examples. The first thing that I want to do is simply make it so that I can get a stable location, hopefully in the center of this particular cup. And so the first thing I can do with this particular example, and also, by the way, notice now it's not finding it anymore. This camera is doing some auto white balancing brightness stuff, which is really can be a problem, and I think there's some ways of turning that off. But in the sort of real world, if you take this to an installation or a project you're making, you're going to want to have a camera that you can turn off auto white balance, all those sort of other automatic settings. But I can, in this example, I can always click and kind of recalibrate the color that I'm tracking. So the first thing that I want to do is, instead of looking for, in this particular video, instead of looking for the single most pixel that is the most red, I want to say, is a pixel red enough? Find all of those pixels and give me the average location of all of those pixels. So let's dive into the code and make that change. Okay. As you'll notice here, every single, the core algorithm of essentially all computer vision, let me look over here for a second. The core algorithm of all of these computer vision examples is this nested loop. For every X pixel, for every Y pixel. And something is really bothering me here. I don't know why these extra spaces are here. And I'm going to sort of do autoform. I need to put some spaces here because I have a problem. Please don't be like me. Live your life with spaces in weird places. Okay, but and you can see here, what am I doing? I am taking, and let's just review this for a second. I have a new whiteboard marker that I've, oh, there it is. Let's just review this idea really briefly in case you didn't watch the previous video. This is a grid of pixels. has columns, which I could number like this, 0, 1, 2, 3, 4. It has rows, which I could number like this. And let's just make those different for the sake of argument. Then it has pixels. The pixels are numbered like this, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, etc. Every single computer vision algorithm that I demonstrate to you will start with for every x, for every y. So it's looking at every x pixel and every y pixel, but then it needs to look up a given pixel here in the one-dimensional array of all of the pixel colors. And the formula for doing that is x plus y times width. And you can see why that would work, because here the width is 6. The first pixel in column 3 and x3 is 3. The next one is 3 plus 6, which is 9. The next one is 9 plus 6, which is 15. Is that right? 11, 12, 13, 14, 15. So this formula is going to be kind of key. So that's right here, right? For every x, for every I, find that pixel location, and then I need to separate out the red, green, and blue components of the color that's coming from the pixels of that video. And then there's this other color called track color. That's the color that I'm looking for, the red. Is that here? Yes, the red cup. And then using the distance formula, and to be honest, I should really not use the distance formula because it has a square root. I should use just distance squared, because then I don't have to take the square root. But I'm not going to worry about that optimization right now. Maybe I'll bring that in later. I'm checking to see if it's if it beats that sort of record, it's the most red, and I have that XY spot. So that's what this code is doing. So now in the next version of this example, instead of looking for the most red, I want to look for anything that is like red enough. So the first one thing we need is a threshold variable. So I'm going to add to this program, I'm going to add a variable called threshold. And I'm going to try this just at like 25. I sort of made that up, 25. I want any given pixel that is within, that's difference is less than 25 from the color that I'm looking for to be considered red. So let's go down to the algorithm. And I'm no longer looking for a record or a closest x or a closest y. What I'm really looking for is like the average x and the average y. And I'm going to make those floats because, yeah, I think that's going to help out in a little bit just in terms of doing the average stuff. And then I also need to have a count. How many pixels are red? Okay. So I need to ultimately what I want to do at the end is have calculated the average, and then I also I need to keep track of how many pixels, because that's how I'm going to calculate the average, by the way. Okay, so now we're looking through, we find the current color, we know the track color, we know that difference. So I'm no longer checking, and I'm going to save this, by the way, as computer vision 2. I'm no longer checking, is that distance less than the record? I just want to know, is it less than that given threshold? If it is red, somewhat red enough, then what do? Average x, I add its x location in, right? I add the y location in, and then I increase the count. Now, those values aren't really average yet. How do you take the average of 5 numbers? You add all 5 up and you divide by 5. So this is what ultimately I'm going to do here. The code's over here. I'm going to add up all of the x's and y's, keep track of how many x's and y's I added up, and then take the average. So now at the end, I can say as long as count, let's just say as long as we found at least 1 pixel, I could say like, you know what, this only works if I find 5 pixels. That might be more accurate. But I'm going to say as long as count is greater than 0, I'm going to say average x equals average x divided by count. Average y equals average y divided by count. I'm going to fill with the track color, give it a stroke, and then draw the circle at average x, average y. So you can see now here, instead of looking for the single most pixel, any pixel within that particular threshold of red is going to be considered red. So let's run this now and see what we get. Now, I don't know if I picked a very good value with value 25, and I should really make that a variable that I can tweak in real time. But let's just sort of see. OK. Now, what I'm going to do is click here to set that color. You can see that's pretty good. It actually is still sort of like moving around. One thing that I think could be useful to do is I could actually show you which pixels I found. And what I'm going to do that, I think, is just do, this is like not so great, but I'm going to draw just like a point there to sort of see a white point to see what it's sort of finding. And the other thing I want to do is I'm going to, just right now, I'm going to map the threshold between mouse x, like the lowest threshold would be 0. Oh, the mouse x goes between 0 and width, and I could have a threshold between 0 and, like, let's just say 100. So this might make things run kind of slow because I'm going to be using the point function a lot, but let's sort of see what happens here. OK. So let me click here. You can see, oh, why are those all? So first of all, didn't I say fill? Oh, point, by the way, is a stroke. And I want to say stroke weight 1. And actually, just for a second here, let's take, let's do this. And let's make this a little bit smaller so we can really see what's going on here. OK, so let's run this. And we should see a white pixel for every pixel it's finding that is red-like. And you can see what it's found here. Now, oh, look at this. So the threshold is very high. So you can see even my hand is kind of within the threshold now. So, and you can see as I move the mouse, that threshold, my skin is kind of like reddish. But as I move over here, you can kind of see what's going on. Now, I want it, wow, my lips, I got to get out of the frame. So you can see now it's quite stable. There you go. So I found kind of an appropriate threshold. I should have a way of like printing that value out so I know. And you can see that it's, whoops, as soon as I move in the picture, we're gonna deal with that in a second. I want to zoom in here. I should be able to, unfortunately my arm is too red, but I should be able to take this off and move this around. And you can see that I have quite a pretty accurate tracking as I move this, and it's quite stable. So you can see that even just doing the average location, again, I have nice lighting in here, I have a green background, I have a very distinct color that I'm searching for. But if this were an interactive tabletop where you could control the lighting, you could have red disks on top of a green table or white disks on top of a black table, then this is something you could do. So I've shown you one improvement here. The first improvement is just using the average. And again, as soon as I introduce another cup, we've got a problem. Look at it. That dot is right in between them. Right? Because it's the average location, which is kind of interesting, but not what I'm looking for. So in the next video, I'm going to look at tracking motion, which I think will be interesting to see. But the video following that, I'm going to show you how you can track each of these locations as blobs separately. OK, so that concludes this particular video. And in the next video, we're going to look at motion tracking frame differencing.